Okay, this problem is asking you to apply the log properties. And the three log properties, three that we're going to look at, is if you have the log of some base, and the two expressions are being here. Let's do BC, and the two expressions being multiplied. We can break that out. Log of the first one plus log of the second one. Okay. Then the second log property that we're going to deal with is log base A of B divided by C. And B and C can be constants, they can be variables, and it's always the same. That means we're going to subtract the two logarithms. Log base A of B minus log base A of C. And then the last property we're going to look at is the exponent property. So if I have log base A of B raised to the C, because that's an exponent, we can bring that C down in front. So C times the log of base A of B. Okay, and then we'll just apply that. And then, of course, we're going to deal with negative exponents and all that on this certain example, okay? This is not the one you asked. This is a similar problem on that. So for question number A, let's see here. I see, it looks like, see how for question A, it looks like there's a pointer here. See how there's a number in front of it? I think I want to do this. I want to undo, I'm trying to get it to be equal to log base B of 4. So if I take that 1/3 and see how there's nothing in front of it, so we want to get rid of that 1/3. So because it's in front of the log, I can raise it as a power. So I can think of that as log, oh, what's going on here? Just a minute. It's fat. I'm going to pause this video and get this pen working right. Okay, I think I got it working. So I'm going to write that as log base B of 64 to the 1/3. Now we've got to pull out our old rational expressions, or rational exponents hat. And this is like we did back in algebra. So I'm going to do this. I'm going to rewrite 64 to the 1/3 as cube root of 64. And cube root of 64 is 4. So this expression is equal to that. Here, let's change that ink. That is equal to that. So I got rid of the 1/3. Now what's happening on a similar note? See how this one has the 1/2 in front? If we bring that up on top, so doesn't that give me log base B of 16 to the 1/2? And if 64 to the 1/3 equals the cube root of 64, what does 16 to the 1/2 mean? I hope you thought square root, and the square root of 16 is 4, and sure enough, that one's also the same. So I better be checking these. Let me clean up my board a little bit. For this next one, I'm subtracting two logarithms. And when I'm subtracting two logarithms, that's this situation. So I can unsubtract them by writing it as a quotient, right? So log base B of 24 divided by 6, and of course 24 divided by 6 is 4, so that is also equal to that expression. Let's see, give me a minute here. Okay, next one, I've got the negative in front, so let's bring that up, because this acts like an exponent, and that's a -1, right? So 1/4 raised to the -1, and when we raise a power, anything to the -1, that means take the reciprocal, and the reciprocal of 1/4 means we're going to flip it, right? So log, I just think of my high school pre-calculus class. We were talking about reciprocal trig functions, which you folks are going to do sometime here, and reciprocal that is flip it, and that's good. So yeah, so that's also the same. And then if we look at this one, just maybe you don't need me to write this out. You see how this is the sum function, which means we can multiply the two arguments. Well, what's 1/10 times 40? That's 4. So that's also the same. So for this situation, they're all the same. I don't know if yours will work out to be that way. Sometimes my math's a little sneaky. Hope this helps.